Now, this is workshop 1A, question 6. Now, if you look at workshop B, when we did the points rectangular to polar and polar to rectangular in the previous video, there are some examples similar to this in the workshop 1B. Try them. If you want to double check your work, you can try them and send me a picture. I'll tell you if you did them right. If you understand the concept of what we did in the previous one, you should have no problem. So here you have this equation, and you want to go from xy to r theta. You know that for the first one, x is r cosine. This is r sine. So if I divide the r sine theta, if I bring this down, cosine theta cancels. So 1 equal tan theta. So this is one way to relate the system. Some people like to say theta equals tan inverse 1. Doesn't matter, it's the same thing. Really, the same thing. So if you do this one, x squared is r cosine theta squared. This one is r sine theta minus 1 squared equals 9. This is r squared cos squared. To square this, you square the first one. This times 2. You square the second one, and this number is 9. If I take r squared common factor, I'll have cos squared plus sine squared. And here, minus 2r sine theta plus 1 equals 9. We know this is 1, so r squared minus 2r sine theta, 9 minus 1. So you just say 2r sine theta equals 8. You can't really do anything more, so you just leave this as it is. Now for the last one, r sine theta, and this one is r cosine theta squared. So this is r sine theta, r squared cos squared. If I bring the r with the r and the cosine with the cosine, I'll do it here so you can see it. I'll bring the r down, so it'll be r squared over r. I'll bring the cosine squared down. So I brought this down and the r down. So r squared over r is r. Now, sine over cos squared, you can treat this as sine theta times 1, and cosine squared is cosine times cosine. Sine over cosine is tan. 1 over cosine is secant. So the answer is r equals tan theta secant theta. Now, the other question you have for the polar system is the area under the curve. So the question says question 7, r equals 2 cosine theta. For the polar system is r squared d theta. This is the formula for the system. Now, problem is you need to know where the curve starts, where the curve ends. It's a little bit tricky. So I don't know if he went over this in class, but it's preferred that you actually try and sketch it. The way to sketch it is you start with 90 degrees over whatever the multiplier is. Like the number in front of the theta here. There is no number in front of the theta, so you divide by 1, so it's 90 degrees. So what you do is, you start with 0 and you keep adding 90s till you finish a complete circle. You have cosine theta, that's the main, and then you need to figure out r, which is double cosine theta. The idea of taking 90 degree over the multiplier, because cosine is always 1, 0, 1, 0, 1. And it's positive, negative, positive. So it's the idea of 1, 0, 1, 0, 1. And when you double, that's a 2, that's a minus 2, that's a 2. So if you want to go here, this is angle 0, 90, 180, 270, 360, 1, 2, 1, 2, 1, 2, 1, 2, of course you have negative, but it doesn't matter. It doesn't matter, so keep it as positive here. With angles, when you do angles, it doesn't matter really. At angle 0, you're 2. At angle 90, you're 0. At 180, this is angle 180, you're minus 2, so you go back to this. At 270, you're 0. At 360, you're 2. So basically this is it. And you'll see that it's good to just go from 0 to 180. You don't need to do anything special. So it's half 0 to 180, and you square this. 2 cosine theta squared. Now 2 squared is 4, and half of 4 is 2. And you're left with cosine squared. Here, we have to use what's called half-angle identity from Cal 2, if you guys remember. The half-angle identity is you go 1 plus cosine 2 theta over 2. And 2, they cancel each other. Now you integrate. Integral here is 1. Integral of cosine is sine 2 theta over 2. And pi over 2 and 0. You plug pi over 2, pi over 2. Here will be sine pi over 2, but that's 0. And you plug 0 will be 0 everywhere. So the answer for the question is pi over 2. Now if I go to the other workshop, there are 2 good questions, question 5 and 6 in this workshop, workshop B. Question 5, they give you the relationship in polar system. They want it to be in XY. So this is 2r sine theta. Here is r equals 3. And here is r equals 1 minus cosine 2 theta. Let's start with the first one. Now, for the first one, if I multiply both by r, I get r squared, and I get 2r sine theta. Now, r squared is x squared plus y squared, and r sine theta is y. That's the idea, is to go from r theta to x, y. This one is rather straightforward, because all you have here is r equals 3. R would be x squared plus y squared under the square root equals 3. And it's supposed to be positive, negative, but since this is 3, you just leave it as 3. Now for the last one, you have to use some identities. Now, cosine 2 theta has an identity. It's cosine squared minus sine squared. So if you use this, so r equals 1 minus brackets, cosine squared minus sine squared. Now, you also know that 1 is cosine squared plus sine squared minus cosine squared minus sine squared. Now, cosine squared minus cosine squared, they cancel each other. Sine squared minus sine squared would be sine squared plus sine squared 2 sine squared. Now, what we can do here, we can multiply both by r squared. So here you'll have r cubed. Here you have 2r squared sine squared. Now, you know that this is r. R is the square root of these two. Cubed, you just go cubed. R sine is y, so r squared sine squared would be y squared. So you can leave it as it is, leave it like this. You can work it out a little bit, but this is good enough. Now, question 6. Now, let me just quickly, my computer needs to be refreshed. Just a second. Yeah, here we go. Now, the question is, length of the curve, and it's r equals e theta over 2, and theta between 0 and 4 pi. The rule says to find this, length of the curve under a polar system is r squared dr over d theta squared d theta. So you go from 0 to 4 pi, you square this, so e theta over 2 squared, and you take the derivative of this. The derivative of this is itself times half, which is the derivative of the exponent, and you square this, d theta. Now, mathematically speaking, when you raise to multiple exponent, you multiply them, so this times this will become e theta. And here, half squared is 1 over 4. And this squared will also be e theta. So now I know I have 1 plus 1/4, so 5 over 4 e theta. I can take the constant out, so I have e theta under the square root. Or basically, e theta under the square root would be e theta over 2. The integral of e theta would be itself over the derivative, so over half. And you have 4 pi, and you have 0. When you divide by half, you multiply by 2, so this is like this. You plug 4 pi, and you plug 0. In fact, since the square root of 4 is 2, these two cancel each other, so you have root 5 e to the 2 pi minus 1. This covers both workshop 1 and B. I want you to look at them. Eventually, I'll write you all the different rules you need to know. If you have questions, you can text me or call me. And I will upload another video soon for the other workshops. Bye.